All right, let's get into it. Today, we're prying open the toolbox that really separates an everyday Terraform user from a seasoned pro. We're going to look at the key commands, the concepts, and the little bits of code that transform a good project into something that's truly stable, scalable, and, well, great. So let's just start with the big question, right? You've got the basics down. You know your plan, your apply, your destroy. But what's the next step? What's the thing that really separates someone just getting by from an expert who's building rock-solid, enterprise-grade infrastructure? You know, it really just boils down to this: knowing which tool to pull out of the box and when. It's not about memorizing every single command. It's about deeply understanding that core set of tools that gives you stability, scalability, and, most importantly, safety. And that's exactly what we're doing here, building out your pro toolkit. Okay, first things first. Before you even think about writing a single resource, a pro always lays the foundation. Look, it's not the sexiest part of the job, but getting this right from the start is going to save you a world of pain later on. This is the bedrock. So what does that bedrock actually look like in your code? What are those non-negotiable first few lines of code settings that you absolutely have to define to get a project that's stable and predictable? Right inside your main Terraform block, it all starts here, with these two. You have to explicitly state the Terraform version you're building for and the providers you need. And this isn't just, for show. It's your first line of defense against things breaking unexpectedly. And speaking of safety, you see that little pro tip? It's a great feature. If you forget to set a variable, Terraform doesn't just guess or fail silently. Nope, it stops and asks you for it. It's a fantastic, simple safety net. Let's drill down on that versioning thing, because it's not enough to just say version 1. What happens when version 1.1 drops and it has some small but breaking change? How do you make sure you get the bug fixes but avoid the new features that might wreck your setup? The answer is this beautiful little thing right here, the tilde greater than sign. We call it the pessimistic constraint operator. Seriously, seeing this one line of code is one of the clearest signs that you're looking at a pro-level configuration. It's so simple but so powerful. So what this little guy does is give you control. It locks you to a specific minor version, in this case 1.0. That means Terraform is free to update to 1.0.1 or 1.0.2, grabbing all those important security patches and bug fixes. But it will absolutely be blocked from jumping to 1.1. This is how you keep your project stable over time. Okay, with our foundation set, we can move on to the fun part, the art of actually writing the code. This is where we stop doing things manually and start building configurations that are flexible, clean, and easy to scale. Now, if you've used modules, you've almost certainly hit this wall. You build a fantastic, reusable module for, say, a virtual network. It's perfect. But how do you get the network's ID back out so the rest of your code can actually connect to it? It's a beautifully simple three-step dance. First, a resource gets created inside your module. Then, you add an output block, and you just point it to whatever attribute you need, like that VPC's ID. That's it. Now, back in your main code, you can just reference that module's output directly. It is the official, clean way to let your modules talk to each other. Oh man, let's talk about repetition. We have all been here, right? You need to add like 10 firewall rules. So what do? You copy, paste, edit. Copy, paste, edit 9 times. I mean, sure, it works, but just look at it. It's a mess, it's hard to read, and if you need to change something, you're changing it in 10 different places. There has to be a better way. And here it is, the dynamic block. This is your secret weapon against that repetitive junk code. Instead of 10 hard-coded blocks, you have one single dynamic block that just loops over a list of ports. It's clean, it's easy to read, and if you need to add another rule, you just add one more item to your list. This is what infrastructure as code is all about. Here's another cool little tool for your kit, the self object. Let's say you're using a provisioner to run a script on a new virtual machine. How does that script know its own IP address? It uses self. The self object basically lets a resource refer to its own properties. It's like the resource is saying, hey, here's my public IP, or this is my instance ID.
It's incredibly handy for any kind of self-configuration task.
All right, our final section. And honestly, this might be the most critical part of using Terraform in the real world, especially when you're on a team. We're talking about managing the state file and ensuring everything is safe.
Let's paint a picture. You and your coworker. You're working on the same infrastructure. You both pull the latest code, and you both run Terraform apply at almost the exact same second. What happens? What happens to your infrastructure? The short answer? Chaos. Absolute chaos. You're basically in a race to see who can corrupt the state file first. You'll get conflicting changes, broken resources, and potentially a catastrophic failure. It is a nightmare scenario, and this is the hero that prevents that nightmare: state locking. As soon as you use a remote backend like S3 or Terraform Cloud, you get this feature. Before anyone can apply, Terraform tries to get a lock. If your colleague has it, you have to wait. If you get it, they wait. It's literally a traffic cop for your infrastructure, and it is absolutely essential for working in a team. Another huge safety tool is the lifecycle block. This thing gives you pinpoint control over how a resource behaves. For example, create before destroy is a lifesaver for avoiding downtime. Prevent destroy is like a safety lock you put on your production database so no one deletes it by accident. And ignore changes is great for when you need Terraform to just leave something alone. As you can see, knowing what you can and can't use here is pretty important. You know, over time, things can get out of sync. Maybe someone made a quick manual change in the Cloud Console. So how do you check what Terraform thinks the world looks like? And then how do you force it to match what actually exists? Two simple commands are your best friends here. Terraform's state list just gives you a quick, clean inventory of everything Terraform is managing. Easy. Then there's Terraform Refresh. This one's more powerful. It actually goes out, queries your cloud provider, and updates the state file to match reality. It's a critical first step before you make any big changes. So let's do a quick tool check. We're locking our versions for stability. We're using outputs to connect our modules cleanly. We're ditching repetitive code with dynamic blocks. We're protecting our team with state locking, preventing disasters with lifecycle rules, and we're keeping our states synced with reality using refresh. That's a pretty solid toolkit. And that really brings us to the end. You have the tools now. You can go beyond just writing code that works and start writing code that is stable, scalable, and safe. So the final question really isn't about what you can build, it's about how you'll build it. You've got the tools to build anything. How will you ensure it's built to last? Thanks for joining me.